conversions that have come in the past CBSE papers of chemistry. Conversion number one is of phenol to N-phenyl ethenamide. I must tell you in the beginning that these conversions are important and they follow more than one route. And that's why I have tried to make them easy for your purpose. So the first conversion is phenol to N-phenyl ethenamide. C6H5OH to C6H5NHCOCH3, as you can see. So we take phenol and we try to remove this OH to make way for something that will be converted into this ethenamide group. So we first react phenol with zinc dust. This removes oxygen as zinc oxide. This H adds to the phenyl ion and we get benzene. The next step is to nitrate benzene using nitrating mixture, concentrated nitric acid and concentrated H2SO4 in the ratio 1:1 to supply nitronium ions. Benzene is converted to nitrobenzene. Now this nitrobenzene is reduced using tin in concentrated HCl mixture and we get aminobenzene. This is aminobenzene, and aminobenzene is acetylated using ethanoyl chloride and we get the desired product C6H5NHCOCH3. We can also follow the route from here, C6H5OH, that is phenol. We can heat phenol with NH3 in presence of zinc chloride and we get C6H5NH2, which is aniline or aminobenzene. That's the IUPAC name of C6H5NH2, which is acylated to phenyl ethenamide or N-phenyl ethenamide. The word reactions have been shown here for your purpose. Now let's go to the next topic, that is conversion of chloroethane to methenamine. Chloroethane C2H5Cl will be converted to methenamine, which is CH3NH2. You can see not only chlorine has gone out, but one carbon also gets removed in the process. So to start, we react C2H5Cl, that is chloroethane, with NaOH aqueous. We get C2H5OH alcohol. The usual procedure. We oxidize this alcohol to get the aldehyde, which is ethanol, and ethanol is oxidized to ethanoic acid, which is then reacted with or heated with NH3, and we get ammonium ethanoate. We get ammonium ethanoate or ammonium acetate, which is heated, and it results in a loss of one H2O molecule. We get ethanamide. Once we arrive at ethanamide, we react ethanamide with bromine in KOH solution, that is Hofmann's degradation, because this two carbon compound is now going to be converted to a single carbon compound, and that is the product that we need, methylamine or methenamine. So a long process, but a very good question to answer. And why these conversions are important? They are important because we can learn the integration of many reactions in one question. And it takes us through a different homologous series. Now, alkyl halides, alcohols, aldehydes, acids, acid derivatives, and finally, you see, amino derivatives. They are all there in this scheme of reactions. So that makes it very important to know the reactions that connect one homologous series to another. Let us move on to another one, that is conversion of propane nitrile to ethanol. CN, propane nitrile C2H5CN, is to be converted to C2H5OH, which is ethanol or simply alcohol. And in the process, you see the C will be lost. N also will be lost. C will be lost. So 3 carbon compound will be converted to 2 carbon compound. And again, as I said, from nitrile to alcohols, you see, this is again, you see, moving over the homologous series. So C2H5CN, propane nitrile, is hydrolyzed in presence of dilute acid. And it gives you C2H5COOH, no loss of carbon here. So it is propanoic acid. Propanoic acid is first converted to sodium propanoate, and then with the help of soda lime, that is NaOH and CaO, it is reduced to ethane. Here you see COONA is lost as Na2CO3, and this H here joins this H5 and the compound becomes C2H6. So once we get this C2H6, we can oxidize it to the next homologous series, which is C2H5OH ethanol. So controlled oxidation of ethane will yield ethanol. Now, this part is known as a decarboxylation because the carboxyl group is lost. It is lost as CO3. Or Na2CO3. So it is lost as Na2CO3. So decarboxylation takes place and we get the alkane, which can be now oxidized to alcohol. Let's see another one. And I think this is the end of the 3 conversions.